Yeah, I think Anupam, we can start now.
Yeah, thank you, Amit. So, good morning, one and all, and I welcome everyone to the 143rd webinar of the Saturday webinar series. I am Anupam Anand, working as fellow at the Manage Hyderabad. So, we have a center over here called the Center for Innovation and Agripreneurship. The is a center of excellence in agribusiness incubation, hosted at the National Institute of Agriculture Extension Management, Manage. It is one of the leading agribusiness incubators in India, where Manage CIA has mentored more than 503 entrepreneurs and incubated more than 310 startups from various focus areas of the agri and allied sectors. We have trained startups in agro processing, post harvest technologies, value addition, farm mechanization, animal husbandry, fisheries, dairy, commodity training, supply chain management, and agri consultancy. The center has assisted and provided relentless support to the agripreneurs, helping them fine tune their ideas and upscale their operations. The topic for today's session is leveraging AI for precision agriculture, smart farming solutions by agri-startups. Precision agriculture, also known as smart farming, has gained significant attention in recent years. Agri-startups are leveraging artificial intelligence and other advanced technologies to enhance agriculture practices, optimize resource utilization, and increase crop yields. We have two speakers joining us today, Mr. Dinesh Kar sir and Dr. Sailesh Kumar sir. To start with the session, I would like to invite the first speaker, Mr. Dinesh Kar sir, and we'll give a brief introduction about him. He is Director Operation and Strategy, Agritech Startup Hyderabad. Dinesh sir is a solution-oriented agriculture professional with 26 plus years experience, having a deep understanding of the agribusiness ecosystem. He helps organizations and startups conceptualize geospatial solutions for the key stakeholders in the agriculture value chain. He mentors students and professionals in developing capabilities for applications of machine learning and geospatial technology in agriculture. He has completed his master MSc Agriculture and MBA by qualifications. He is the author of two books, Sensing Agriculture from Space and Nine Rules to Geospatial Consulting. He has developed solutions for crop insurance, crop health monitoring, crop yield production, crop prediction, crop site suitability zonation, crop intelligence using machine learning techniques and on satellite. His few international projects include Philippines for World Bank, Mozambique for agriculture ecological zonation, Saudi Arabia for agriculture chain dynamics, Sierra Leone for a land development project, Malawi for a soil erosion assessment, and many more. He has also worked at the Central Research Institute for Dryland Agriculture, CRIDA, which is under the Indian Council of Agriculture Research, and at the National Remote Sensing Agency of Department of Space, Government of India. With this brief introduction, I'd like to hand over the session to Dinesh sir. Welcome, sir.
Thank you, Anupam. Thank you, Amit, and thank you, entire Minus team, for giving this opportunity. Hope I am audible to all of you.
Yes, sir, you're audible, sir.
Thank you. Hope you are able to see me also. Good. So the topic, as we all know, this is leveraging AI for precision agriculture, smart farming solutions by startups. So as we can see here, there are multiple terms. There is an AI, there is precision agriculture, there is smart farming solutions, and there is agri startups. So what I'll be doing in the next 20 minutes is I'll try to touch every single word of it. So we'll not restrict ourselves to AI. We'll be talking because AI is just a kind of a, I can say it's just a tool. So that's what we are going to use it for precision agriculture as a part of smart farming solutions. And nowadays it is been mostly used by agri startups. So this is how I'll be taking up the entire next 20 minutes. Hope you all will be there with me. And my presentation flow will be this way, that we'll first understand what is smart agriculture. Then we'll try to understand the importance of technology in agriculture. I'll touch base on the overview of AI and its potential in agriculture. Some case studies quickly I'll run through, which I have done and which I have been part of with other startups. And then we'll get into the question and answer after all the presentations are over. Let me take this first slide because when we talk about smart farming solutions, it was written in the title slide. some people also call it as smart agriculture, agriculture 4.0, agri-tech, digital agriculture, or data-driven agriculture. This is what is the present and the future of agriculture. We all are talking about these terms. Earlier, we used to talk about mechanized agriculture, green revolution in agriculture, or some genetic agriculture, high yielding varieties, and all such things. But now it is all about data information. So we are all going to be data driven agriculture. So now why and how it has come up. So let's go a little back and try to get the feeling of it. See, this is the first revolution when it has happened. I'm trying to explain this part that why it is called as 4.0. So the first revolution, like we were the people, we used to hunt and gather our food. And suddenly we became settled. So rather than going to the forest, collecting our food, and bringing it to one place and eating it, we started cultivating it one place. That was the first revolution that has happened. We became settled agriculture. Second was the British agriculture revolution, where these people, they started developing and they started calling themselves as farmers. And there was some mechanization happened, some implements came in, the land conversion from pasture land to agriculture happened. Uh, People started also learning about the crop rotation, the seasons, the seed, how to put the seed, when to harvest, all those things. Third, which we are all part of, is the third agriculture revolution, that is the green revolution, where exactly what happened was there some need came in. There was a need to feed the population. So how it can be done? The land was limited. So we have to grow some, we got into high yielding varieties. If you have high yielding varieties, then you need to definitely put some chemical fertilizers, agrochemicals, improved method of irrigation practices, everything started getting into it. And also during this green revolution, the crop package of practices were developed. Like when you have to do land preparation, when you have to do seed treatment, when you have to do sowing, then you have to do 30 days after sowing what application, 45 days after sowing what application, 60 days after sowing what application, then when to harvest, when to store, how to store, the entire package of practices were developed. So farmers started following all those things one after the other. And to some experts, this is the good part also. And nowadays, some experts tell little other side of it also. Because chemical fertilizer have gone in, the package of practices were so clearly defined that uh, you did not get time for the soil to regenerate, for the climate to play its role. But whatever the climate is there, exactly 30 days after sowing, we started putting the fertilizer. 45 days, okay, next fertilizer, pesticide, everything we did it. So that was the green revolution. Now we are in 4.0, where we don't talk about cultivation, sowing, harvesting, nothing. We are talking about drones, satellite imagery, IoTs, soilless agriculture, headbots, agriculture robots. So these are the terms which we are talking about in 4.0. Now, if you look at all these things, whether it is a soilless agriculture or robot or controlled farming, how they are working, something is going behind it. So that is all the data which has been collected, data is converted into information, information has been put into some algorithms, some models have been built, and then you are getting your results or the smart farming done. So this is where we are today at 4.0. And what was the reason to be here? Like in the second revolution that happened, the machinery, the one farmer was supposed to feed 26 people. So he started using all those tractors, soil cultivation, all those things. in green revolution, the requirement was one farmer has to feed 155 beans. They started working on the crop management practices, crop package of practices, everything. Now, by 2050, the need is one farmer has to feed around 265. And the technology they are going to use, it is all going to happen through technology. Now, the thing is, when we talk about technology, sometimes some question comes to people like us who are basically the agriculture people, not from the physics, computers, or mathematics people, not from the coding side and all. I'm purely from agriculture. Most of you also must be from agriculture. Like, suppose if I, instead of seed, if I put data in the soil, can it give the crop? Because we are talking about data. If I put the data, can it give the crop? If I put, let's say, IoT sensor in the soil, can it give me a crop in the next day? No, it is the digital agriculture technology is for whatever term you say, whether it's AI, machine learning. See, it is to improve the efficiency, improve the productivity, improve the sustainability. So for that purpose, this digital technology is used. If I have to give an example, uh, let's say earlier we used to cook food in normal chula. You know chula? We used to put wood into that, put the fire, and then make our food. We are making the food. Then came the stove, the batti wala stove. We started putting the fire and there was a stove. What we are doing is cooking the food only. The development is happening. Then was the pressure wala stove. Again, we are cooking it, but we are putting pressure. Then came the gas stove. Now there is a, you have microwaves, you have grilling machines, you have induction machines. Everything is there. What is happening is the cooking is same. You are cooking the food, but the way to cook, the efficiency of cooking, that has improved. So this is there in the agriculture. You are not you're not going to change the seed. nahi hai. I will put only some data and I will get the crop. I'll put some numbers in the field. Excel sheet देख लेके डाल दूंगा sowing. So 30 centimeter below the ground, Excel sheet will become a crop. So this is it. The agriculture 4.0 also came up with some many things which we are all talking about. There are some global problems, the food production, water scarcity, soil is getting desertified, it is getting degraded, climate change is happening. You know, currently, what is the stage of our tomato price today? It has gone to 100 to 120. It is all because of climate change. There was a sudden increase in the temperature, delay in the rainfall. People stopped cultivating. Some people have even uprooted the tomato and started growing the beans over there. So there is no stock available now for the tomato. So whatever the less stock was there, that is only coming out. So prices increase. Now this is one side. Another side is, I think Amit might be knowing. Amit, you are from Maharashtra also. You know that, like Maharashtra, there will be high production also. Suddenly there will be so much of production of tomato that people will be throwing tomato in the roads and they won't be getting. So this is all because of climate. These are the global problems. Now, when I talk about localized problems, shortage of labor, rural youth is moving out of farming. There is lack of knowledge. See, people are still stuck into their package of practices. If there is a change in climate, if there is a change in rainfall pattern, but the package of practice is still remaining the same. And they are not changing it, they are not adapting it. They know it. They have seen it. They are very well versed with YouTubes and all. They have seen it. But people like us, the extension activity has to reach there, convince them, demonstrate them, then they will adapt it. So these are some localized problems. For this, we have some solutions. Crop productivity improvement is required, sustainable agriculture is required. These are the broad terms. Now, suppose let's say if I say I will introduce high yielding variety, short duration variety. It's a subcategory of crop productivity improvement. Uh, Carbon farming. if I introduce water conservation practices by which I can reduce the emission of methane, it's a carbon farming practice. If I put cover crops and increase the carbon content of the soil, it's a part of carbon. So broadly, in this 6 terms only, the solutions are there, for which now we are using this technology. When combined, we do both the things. This is our digital technology of 4.0. Now let's compare it traditional versus digital. As I've given you the example of cooking. See, collection of data in digital also you have to collect the data. Only thing is there we were sending our field team or the farmer or surveyor. They used to go and do it. Now I can send my drone. I can take the satellite images. I can program the satellite in such a way that okay, next 2 days give me the data. Or I can go back to history, collect the satellite imagery, collect the data. The modeling and research analytics used to happen through some statistical packages. Now it is happening with some machine learning, deep learning. The deliveries used to happen like we used to publish papers earlier, scientific research papers. Those were our references. And nowadays, you have dashboards, you have platforms, you have robots doing your delivery, you have your robots doing your things. Machines are part of all the things. So the things are same, the way of doing us, and it has to change. And it needs to be changed if you have to increase your efficiency. So the challenges, as I mentioned that what was the traditional challenges are the limited access to real-time data. Today, if I have to collect, let's say now the Kharif has started, I want to collect the paddy information from all the paddy growing states. There are 16 to 17 states which are growing it. I need a huge manpower to go and collect the data. By the time they reach the field, collect the data and come back, it will be 2 to 3 months. So the real-time data I'm not getting it. But the same thing, if what I do, if I collect a satellite imagery of today, immediately I can cover the entire state or entire country within no minutes. So inefficient resource utilization. Now the resources there, I have satellite imagery, I have drones with me, but not able to use it efficiently. And for everything, there is a high level dependency. For spraying, you need labor. For sowing, you need labor. For transportation, you need labor. If that can be changed into agricultural robots, tractors, uh, driverless tractors, so it is all solved. Then lack of precision and accuracy. Most of you might be aware of it. When the data is collected, how much precisely they are doing it. Most of the time we have seen that seed companies, fertilizer companies, they tell that okay, the data that comes from the field is all cooked data. They will sit in some shop and fill the form and then they will come back. The reason is, see, some trend is there. You just put the trend on it, fill it up. Number two, there are some inaccessible areas you cannot go there. So the data automatically gets cooked, or you put some number in percentage. You came to know that, okay, 20% has increased. So last year data, you take it up, you add some 20% and then publish the data. This is what is that. So when we talk about AI, see AI, if I have to talk in a simple terms, it means perceiving the information, synthesizing the information, inferring the information, and then demonstrating or delivering the information. So perceiving the information, the data or the information is coming, and you are asking it to act in some way. If it is a human will act in many ways. They will think all the, okay, ऐसा होगा तो कैसा होगा, वैसा होगा तो कैसा होगा, all those things. But in AI, you frame the rules, everything. Okay, these are the defined situations. If that fits in, you go synthesize the data or information, then you infer it and deliver it. Why? To optimize the productivity, reduce your resource wastage, and ensure sustainable farming practices. Now, the second line is very interesting. By leveraging real-time data, predictive analysis, and automated AI empowers farmers to make informed decisions. So this is for making a better decision. How it works? It's very simple. Rather than a human, you have a device on the farm. Analytics are happening in the cloud, and actions are being taken either in the mobile phone or in the dashboard or in the robots or in the tractors, whichever instruments are there. Now, when how the AI moves? See, there is a data and there is an information. You might have gone through some of the websites like weather resource information system, land resource information system, irrigation information system. These are the information systems. What they are doing is some data is collected from the ground, they are converted into information and then present. For example, like if in our college we have seen our weather stations were there. We used to go and collect the temperature data, humidity data. What we used to get it? Okay, 26, 36, 85, some numbers. These are all data. When I put something added to it, 26 degrees Celsius on so and so date of Hyderabad, 36 degrees Celsius for so and so date for Nagpur. So now I'm putting information to it. And if I present it in a pictorial way, tabular way, it becomes an information system. Similarly, if I'm able to take some decision of it, if this is the humidity situation today, and if this is the rainfall, if this is the temperature, this is the humidity condition, I can take a decision that, okay, there might be some rains, so I need not have to irrigate. This is the decision system, the support system. So I put my decision based on the information. What AI is doing is, it is doing the reverse way. You just put a question, do I need to irrigate? Put a question in your expert system or in your mobile phone or wherever. It goes back, takes the knowledge, digs out the knowledge, whatever the rules were there, then they will get into the information from the data and give you the answer. This is what is happening. You are watching YouTube every day. So whatever you watch, the next day you will see some similar kind of videos will be appearing on the next day. What it has done is it has gone back, it has done its knowledge that okay, this person is watching this kind of video, collects all the information, whatever was stored in the system, based on your data, who are you, what is your age, what you are doing, and then it produces you the answer. So through AI and analytics or through machine learning or through digital technology, what kind of things we can do and what kind of things the current startups are doing it. One is a descriptive analysis. What has happened? Like if I have to take an example, let's say one agriculture commodity trading company is there. They want to know, I am a cotton trader. So I want to know where are the cotton crops available. That's all. So you take a satellite imagery, you do some analysis, put into some machine learning, and then AI tool automatically it will give you which are the places where the cotton is available. So insurance people, they want to know where damage has happened. So you take a satellite imagery or you fly the drone, it will give you where the damage has happened. So whichever has happened, you can tell. Another is diagnostic analysis. Using this technique, you can also tell why it has happened. Suppose if any damage has happened to the crop, using your AI tool, you can tell why this is whether it is a crop pest damage, whether it is an insect damage, whether it is a damage due to flood, damage due to drought, or damage due to human intervention, damage due to animals. So that diagnostic can be done. Predictive analysis. Like you can even predict that okay, with this situation, this is how the crop is there, this is the temperature now, this is the humidity. I'm expecting in another 5 days. So I can predict whether the disease will happen or not. So let's take a decision and start applying some fertilizers. So this is a predictive analysis. You can even prescriptive analysis. See, when you have done the descriptive, diagnostic, and predictive, you can even as an expert, you can suggest whatever our advisory systems are there, they are not prescriptive. What need to be done, prescription can be given.
Yeah.
These are all the things
Dinesh,
which you have.
Dinesh, sir, sorry to interrupt
Another
you. Could
2
you please
minutes.
summarize? Yeah. Okay, sir.
Yeah.
2 minutes. Yeah, please.
Yes. So these are some of the technologies which are being used. IoT, precision farming, drones, big data, robotics. Some of the things that we can do it in AI, crop monitoring, precision farming, irrigation, yield predictions. These are the technologies which you all people know. I will quickly take you through uh, some of these. Yeah, these are the startups which they are doing it. These are the areas where they are actually working it. Uh, I'll be sharing my PPT. You can take it from there. Some examples of these are the startups of what they are doing it. These are the startups which are in this, in the different column. You can see what they are doing it. Who are there in the farming area? Who are there in the data collection decision system? And what they are doing it. Again, within that, who are into the production side, who are in processing side, who are in distribution side, retail side, consumption side. And based on the area also, their market segments are also defined and what technologies they are using it and where our technologies are. See, most of us, we think from the international perspective, okay, America में तो बड़ा 100 to 1,000 acres का land है, they can use it, we cannot use it. But we are using it, and these are the states where we are already there. Quickly, I'll run through one case study. This is, we have done it using machine learning and AI. This is a banana plantation. Just took the photograph, immediately analyzed, we found where are the gaps, and then based on the index analysis, which column is giving the good, healthy, and the left hand side, you can see they are not behaving properly. Moisture wise, irrigation wise, it is all good. So that means the crop is not good, management is good. Insurance wise, you can collect the data, put it in the dashboard, get your plot in the field, take a satellite imagery, get it classified, and run the platform. See, 1 year back, you can go and perform the analysis. If you can see my mouse, there was a dip here. So that means something has happened here. Immediately, farmer would have taken a decision and applied something. So again, it has grown well. This is all things have been done using AI. You can compare it between 2 days, how earlier it was and how later it has become. Within the plot, you can do what has happened, whether it is a growth problem, canopy problem, flood problem, disease problem. Using drones, you can see, analyze the data. One last case study, if you permit me 1 minute, Amit, I'll take it. See, satellite imagery is there. See, we tell about that precision farming only happens if you are having a large area, say 500 hectares. If my village is a 500 hectares, that also is a land only, no? So if I'm taking this as one village, in which hundreds of farmers are there. So now keep a quick, means very focused your view on the slide and on the date. See how the image is changing. It's of June 6th, 11th June. All the dark patches are your moist and water area. Red is your vegetation. So moisture is increasing. Moisture is increasing again. See, it has increased. Now the crops have come. Full crop has come, completely covered. Now all the sowing is completed and people are there. Now same thing, let me analyze it through moisture index. I have not gone to the field. Everything system is doing it. See the moisture. All the blue color are the moisture. Light are the less moisture. So the moisture is increasing, 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 covered. Now, if I have to tell to someone which farmer is having problem, how do I do it? I just put a village boundary on it, do the same analysis. See now, each plot wise I know where moisture is there, where it is not there. Blue is the moisture, yellow is average, and red and orange are the bad patches. You can see now. So now at this stage, I can say only few farmers of the yellow patches, I can go and tell them that please irrigate your plot. This is how it is done. Same way for the health, where the health problem can happen. You can detect it plot-wise. So exactly site-specific management can be taken up. So to conclude, as I told, AI or any digital technology is for our efficiency, productivity, sustainability, and flexibility. Thank you so much.
Yeah.
So Amit
Thanks,
has
sir.
already
Thanks,
explained all of
Dinesh,
this.
sir,
Thank you so
for
much.
the very effective and simple way to explaining these very, I'd say, for common man, it's a very difficult topic to understand AI. But you explain well from the agriculture revolution from ancient year to the 4.0 nowadays, what the digital era is going on. And a very wonderful case study on the crop monitoring system by using AI technology. So I hope the startups who joined here and the participants get many insights from your session. Now I request to my colleague Anupam to introduce our second speaker. But before that, I'm requesting to participants, if you have any questions, you can put in the chat box or you may raise the hands to ask directly questions to the speakers. So yeah, Anupam, now you can introduce our second speaker.
Yeah. Thank you, Amit. So our second speaker for the second half of the webinar is Dr. Shailesh Kumar sir, who is Chief Data Scientist, Center of Excellence, Artificial Intelligence, Machine Learning, Geo Institute. Dr. Shailesh has 20 plus years of experience in building a world-class team of AI researchers, data scientists, big data engineers, software engineers, architects, product managers, and visionaries to help this potential, pushing the boundaries of what AI can do and advancing the state of AI art in AI. His expertise areas include machine learning, artificial intelligence, deep learning, quantum AI, computer vision, speech, language understanding, knowledge graph, conversational computing, and IoT. Over 20 years of experience in building and innovating AI and ML solutions across a wide variety of domains, which include search, banking, retail, finance, insurance, telecom, manufacturing, security, healthcare, agriculture, and education. His areas of expertise includes artificial intelligence, machine learning, reinforcement learning, natural language understanding, computer graphs, computer vision, graph theory, game theory. And his speaking engagements have included, he has been a vocal speaker at TEDx, World Economic Forum, NASCOM, UNESCO, Product Leadership Forum, Analytics India, companies Google, Microsoft, LinkedIn, NVIDIA, Honeywell, Sony, MX. His startup forums include Calgary Capital, Nexus Ventures, T-Hub, Ministry of External Affairs, Government, Income Tax, Customs, and universities such as ISB, Triple ITs, IITs, BITs, AGs, and INSOF. With this brief introduction, I'd like to hand over to the session to sir. Over to you, sir.
Thank you. Thank you, Anupam. Good morning, everyone. It was a great pleasure to hear Deepak sir earlier, and he talked about a very nice overview of what agriculture has done for mankind, how it has evolved, and how it is going to be in the future. And today, I'm just going to take the same theme forward and talk about not just agriculture, but how to think in a system way to build platforms for the future, right? So one of the things about the context we are in today, we are living in a very special time. We have various technologies that have come together, right? The internet, connectivity devices, cloud, AI, ML, IoT, blockchain, AR, VR, and all that. So I think this is a very beautiful time where many technologies have come together. And I think the great innovations that will happen now will utilize multiple technologies together to create a better future for mankind across all domains, right, including agriculture. Now, among these technologies, AI is considered a very profound technology. And the reason is what we will understand, as we understood earlier, if you take human intelligence, scale it to a very large computer, like a cloud computer, and put it all knowledge that is there, you can just imagine the power of what that can do, right? So AI is definitely one of the most important things a human race has ever done. And we are now starting to realize its full potential when we apply it to social use cases like agriculture, healthcare, education, smart cities, safety and security. And that is the next 20 years of AI. We are going to really inundate these social sectors with AI applications. Yeah. So if I think about what is intelligence, right? So it's really, sir has talked about the various ways of intelligence. It's really the art of learning from data, from past mistakes and improving. It's really understanding what a satellite image is saying, what a soil IoT is saying, what a thermal imaging is saying, what a photograph of a farmer is saying. How do you understand images? How do you understand time series data? How do you understand videos, right? How do you understand something? And how do you think about it? What to do next, right? I have done this, what to do next? I've done these three things in the past, what to do next? What is the most optimal action? And then the next level of AI is creativity. How do you create new strategies, new plans? How do you create images and videos? How do you create like chat GPT text? So that is the next level. And the last level is consciousness, where intelligence can itself reach a level which seems like a conscious level, right? So we're not going to get there anytime soon, but now we have mastered the art of learning, understanding, thinking, and creativity. These are four dimensions of intelligence. How do we apply them to various sectors is now up to us. Yeah, so that's a very beautiful time to be around. Now, when we think about a great product like agriculture system of a country or Google Maps or any of that, we need to think about 4, 5 I's, right? One is the infrastructure. Whatever we have done on one farm, can we scale it to the whole country, right? What have we done for one crop? Can we scale it to all the crops, right? So the idea is, how do we scale? How do we create interfaces that are very beautiful and intuitive? A farmer doesn't know how to type in English. He only knows how to use a speech-based interface. So how do we create applications that are very intuitive and natural? Can a farmer just take a picture of a crop and AI can actually deliver the right pesticide to him, right? Or a satellite data can give you the right insight. Every morning you open something and it speaks to you ki aaj kitna pani dalna hai, right? So how to make interfaces very beautiful? How do we make intelligence continuously learning? Last time, whatever mistakes we did, how do we improve and next time we can do further better? How do we make instantaneous decision? If there is a rain warning, how can we inform the right farmers about the right actions depending on what crops and stage their crops are? How do we create decisions that are instantaneous and not just yearly or annual or kharif and all that, right? And how do we build an integrated system? And what you saw just now, right? Satellite data, soil IoT data, weather data, all this has to be integrated with the knowledge of agriculture, the rules to deliver value into the devices and application. How do we think about agriculture of a country as a single integrated system made up of thousands of APIs? That is our next challenge. And how do we make it work seamlessly, right? So obviously, a lot of sectors will transform. We'll focus on agriculture today. So when I think about a domain as complex as agriculture, the first thing I do is, instead of saying, let me solve one problem here or one problem there, I think about all possible AI contributions that can be done via, into the field, right? So we list down all the things we need to build together, right? We need to build crop models, soil models, computer vision models, which includes remote sensing. We saw examples, agriculture supply chain practices and advisory, personalized omics, genomics, and biomics models. So there are a lot of models to be built in AI. One or two models here and there is not going to solve the problem. So that is the first thing that hits you, that to solve a complex ecosystem, we need to talk about and integrate all these AI capabilities into a single platform. So that will be our great challenge as a team, right? Now, let me just go through some of these knowledge graph. So today, so far we have written very nice books on agriculture and many other fields. And so far, these books were written for humans to consume, right? We have created data for humans to consume. But going forward, we are going to need digital version of that data. So for AI to consume. So we are going from data and knowledge for human consumption to AI consumption. It's a big transformation that is happening in every industry. And knowledge graph of agriculture is a very, very important construct. It needs to adapt to regions and crops and locations and soil types and all of that. So how do we build that at a country level? Make sure all agriculture experts can participate in that exercise, correct each other's thing, and make sure we get a very robust, holistic, and confident knowledge graph of agriculture for India or for the world. So that is the first These are foundation building blocks that can be built and need to be built. I'll just show some case studies. Sir showed some crop anomaly model. So now imagine a farmer takes a picture on a crop, and we can actually build models today with deep learning and all that, where we can collect a lot of data from web and say, give me all crops of this type with this disease, and lots of images will come. And now we can ingest all that data, upscale them and standardize them, add some noise on top of it. And now we can build models for what is the crop, what is the stage, what is the disease, what is the pest. Now imagine with one picture, I can predict so much. And now with that prediction, I can do so many actions, right? So crop anomaly models we have built now, we are very, very accurate on certain diseases, 100% almost. And still there is a lot of work to be done on other diseases. And it all depends on the complexity of the crop and the images and all that. But we need to continue to build this API, right? So knowledge graph APIs, crop anomaly APIs. Sir talked about precision farming, where farm boundary is important. So today a lot of work is going on with satellite data in just detecting what is the farm boundary, assigning it an ID. Like we all have an Aadhaar card. What is a farm Aadhaar card or a whatever, and it needs to change if land is exchanged or merged and all that. So satellite data can do that. And what all it can do on top of it, sir already showed some examples. A lot of applications of satellite data. Crop selection and planning, today we can look at what crop to grow, what not to grow as a joint optimization problem, right? We cannot just say everybody grew tomato last year and this year nobody will grow tomato. What will happen is that will create a big problem. So how do we systematically build models where we say, look at all the input data of all types in the past, and then build the right crop recommender systems, yield predictor systems, input, how much it will take to grow that crop, right? Water and fertilizer and all that. What will be the market value of the crop when it is done, and how much profit you will make. So imagine if these AI models can be built, they can be used to give very nice advisory to farmers, what they can grow, right? And personalized advisory is a very important area. Today, as Reliance Foundation, we can only handle 800 calls a day when a human agriculture expert is sitting in the back. But now imagine if we build AI components, like, no matter what language, we can recognize what text, what you're saying, what is the question, understand the question. And now imagine an AI-based expert, which also has a farmer profile that says, based on satellite data, lat long, soil IoT and weather, I know your profile, what you're growing and all that. I have the knowledge graph. I have all the three data types, and then I can give you information, what to do. I can give you content, what to watch, how to apply a pesticide, and I can even deliver the pesticide and fertilizer on the ground because we have people on the ground, right? So we need to be able to do all this digital, physical together as a this thing. Yeah. So my vision and the vision of all the, at the top leadership of agriculture in the country is to sort of create an agriculture operating system. So instead of saying there are 500 APIs, 2000 startups, how do we all come together and plug in our stuff into an overall operating system so that, we have events coming on one side, weather, pest events, soil events, mandi events, all that. And we have farmer lake where we know exactly what is going on in every farm. We have content lake in every language. We have content for everything, all practices. We have agriculture rule-based systems that are created by local agriculture experts and all that. And we have the knowledge graph of what crop, what chemical, what everything. Can a AI system take these events in real time from every farm and generate all kinds of advisory at a farmer level, district level, government level, export policy level, drone, what to do, equipment level, warehouse level, right? So this is the kind of an operating system thinking that is needed to transform agriculture. We already know how to build bottom-up systems. We now need to integrate all of them and to create an operating system for agriculture. So supply chain problems are gone. We have a dashboard of the country every day. I know exactly which crop is coming on what day, how much is the demand, how much is the supply, where do I need to put more vehicles, more tractors, more fertilizer. So we can drive so many decisions in agriculture if we had a holistic operating system running for the domain, right? So the idea is, how do we do this as a team, as a country, right? So the idea is, imagine that all startups have their own APIs, which are very good at what they do, but the system needs many stuff. So I'm giving an example of healthcare here. So you have multiple sectors. Within that, you have multiple beneficiaries. Within that, we are using multiple apps and products. Within that, there are some services that are AI services. Within that, there are certain services that are, let's say, speech or vision or language services. Who is going to build them? So the idea is, can I create a marketplace where anybody can produce AI models and they are available in a marketplace and anybody can consume it to build end-to-end solutions? Right? End-to-end solution is what a farmer needs. He doesn't need 20 apps, one for agriculture advisory, one for mandi prices, one for checking the weather, one for something else, ordering fertilizer and all that. He needs an integrated, personalized assistant for all things that he needs. And how can we all integrate into one personal assistant to give him the best that is possible, right? So that's kind of the goal. So the idea is, how do we think about a marketplace of AI for agriculture is the theme. And, if this is something that resonates with you, we can talk together and work with the managed team to figure out how do we come together to create such a marketplace, right? So there are producers who are academic institution researchers on one side, and consumers who are building solutions for farmers on one side. And how do we come together? Yeah? All right. How are we doing on time? Just 1 minute I'll take to show a video of
Sure,
what I
sir.
mean. Yeah.
No issue, sir.
Yeah.
What's your phone number?
So this is an app that was built by, let's say, somebody in Kerala for the fishermen. So this is a fisherman app, and I want to show you the power of this marketplace thinking through this, right? So in the fisherman app, whenever he selects English as a language, the phone speaks to you and says, what's your phone number? But whenever he selects some other language, so now he's selecting English, it is saying,
What's your phone number?
what's your phone number? Audio is coming, no? I hope.
Yes, sir. Yes, sir. Video, audio is there, sir.
So now when he chooses Telugu or Tamil as a language, the audio is not coming. So imagine, this guy is expert in fishery. He doesn't know anything about speech and text models, and that is the consumer of AI. Now imagine somewhere else in the country, somebody in the country has gone to a website, let's say AI Marketplace for India, and he says, I am very good at text to speech or speech to text models in some language, Telugu or Tamil or whatever, right? And he has uploaded their models in this. And he doesn't know that this app exists. So this is like, like we don't know the potato was grown by which farmer, complete decoupling, and see what happens.
Me phone number?
And suddenly this app has become speech enabled, right? And now the fisherman can, the fisherman doesn't have to read also, it is speaking to him. So this is how together, if we create a marketplace mindset, we can really help each other out and produce the best AIs that we have, contribute to the system, and the consumers can create a holistic app to help the farmers. And you don't even have to know about each other, right? You can just use each other's API. That is a need of the hour, because agriculture is a very complex system like we saw. It requires many kind of AIs to come together: optimization, prediction, deep learning, reinforcement learning. How do we bring it all to the farm? That is the challenge, right? So the key principles: integration first thinking. How do we integrate a complex system with all its sensors on one side, decisions on one side, dashboards on one side, policy makers on one side, advisories on one side? How do we integrate all this? Like our body is an integrated system. How do we standardize everything? Today, the naming convention of everything, right? The way we write rules, all that has to be standardized, right? To create an open architecture so everything can talk to each other. How do we personalize all our decisions? Every morning, a farmer should receive a WhatsApp or SMS, what to do today, based on the new weather patterns that are emerging, not the old practices like Sir was talking about, right? So how do we make it very contextual and personalized is the theme now. It is possible because we know so much about a farm. How do we democratize? How do we bring farming experts, agriculture experts on one side, data scientists on one side, sensor companies on one side, startups on one side, policymakers on one side, and even farmers on one side to help out with the labeling task, for example. Take a picture of their crop every day, right? Finish writing up their whatever, right? And say, this is what I did today, because that data becomes a continuous data. So how do we democratize the process of producing and consuming AI? And how do we build inclusive systems, not in English, but in all Indian languages, not only text, but also speech, and take a photograph? How do we build systems that are very inclusive and easy to use? And how do we build trust in people and say, look, AI is helping you do a better job. Try this for a few times and see what happens. And then automatically, when they see a crop yield increasing and profitability increasing, trust will build over time, right? And how do we not misuse this data for something else, right? Like increase the insurance of a farmer because the satellite data is showing something. So I cannot do that. How do we build trust by using the data for the right purpose? Okay. So I'll stop there. We are very happy to partner with anyone, contribute this through Reliance Foundation. I have a team of data scientists working in agriculture. We need a lot of help in improving these systems, building more systems, and integrating them in a holistic place if somebody can take that lead. Yeah. Thank you.
Yeah, thank you so much, Shailesh sir, for the wonderful explanation about your session in AI. And you talked mainly the things that how one can, by using the six guideline principles, one can develop their own solutions in the artificial intelligence for the maybe any other domain, not only the agriculture. So now I'm requesting the participants, if you have any questions, you can raise the hands to directly ask questions to the speakers, or you may put in the chat box. So I'm going to take few questions are there already in the chat box. So we'll go to the first question that is asked by the Mr. Harish. So the question is, what is your opinion on applying AI on soilless farming techniques like hydroponics, aquaponics, which are emerging now in days, and a vertical farming? So can we utilize this technology in this soilless farming? So what is your take, sir, Dinesh sir, or maybe Shailesh sir, you can also add.
Yes, sir.
Yeah,
Go ahead.
yes. See, the question, if I have understood that, let me also read it.
Yeah.
What
So
is your opinion on AI or soilless farming technique like hydroponics? Do you think AI plus soilless farming will be answer to majority of the problems in agriculture in India? See, soilless farming cannot be the solution for the majority of problems, but definitely it is contributing to it. And another thing is, it is for the urban population where the consumer pattern is changing. We are looking for a different kinds of leafy vegetables, organic vegetables, kind of a thing. People are going for such kind of a thing. Another thing is, when there is a less space, no crop can be grown. There, people are going for terrace gardening, soilless farming, vertical farming, all those things. And yes, AI can definitely, and AI is the important tool in this thing, because AI can understand what is the temperature of water, what is the temperature of that entire system, what is the fertilizer content in the water, which can go, because it is not taking the nutrients from the soil, it is taking from water, it is taking from air. So AI is the main, I can say, the driving tool in all these things. Hope I
yeah,
was able to answer it.
yeah, Harish, I hope you got the answer. We'll quickly go to the one of the participants has raised his hand. Vivek is there. Saurabh, could you unmute him? Yeah, Mr. Vivek, can you hear me? Just check once. Yeah, Vivek, can you hear me now? Hello, Vivek, are you there? Yeah, we'll go to next. Archana is there. She already raised her hand. Yeah, Archana ma'am, can you hear me? Hello, Arjuna, can you hear me now?
Yes, sir. Yes, sir.
Yeah, ma'am. You can quickly ask the
हाँ,
question to the speakers.
ओके सर। मैं खुद फार्मर हूँ। मैं फार्मिंग करती हूँ अपने खेतों में। तो मुझे जब हम एआई या टेक्नोलॉजी की बात करते तो मुझे एक बहुत बड़ा गैप दिखता है थ्योरी और प्रैक्टिकल में। मतलब मुझे लगता है कि जो हमारे किसान हैं वो इतने फैमिलियर नहीं है टेक्नोलॉजी का। जो ट्रेडिशनल तरीका है ना वो उनके अंदर इतना इनबिल्ड हो चुका है कि जैसे अभी मैं अपने की छोटी छोटी जो नई टेक्नोलॉजी आई है वही उनको अडॉप्ट करने में इतनी प्रॉब्लम होती है, वो उसके यूज टू नहीं। तो ये हम कैसे करेंगे? मतलब ये जो गैप है इसको कैसे हम ये जो ब्रिज है उसको कैसे ओवरकम करेंगे?
शैलेश सर, what
हाँ,
your
बहुत अच्छा क्वेश्चन है। तो क्या है कि जैसे आपको अगर गाड़ी चलाना सिखाना है किसी को, तो उसको ये बताने की जरूरत नहीं है कि इंजन कैसे काम करता है। आप सिर्फ उसको ये बताओ कि गाड़ी कैसे चलाना है ना। तो अगर अभी आप पहला जो इंटरफेस है विद द फार्मर शुड नॉट बी कि एआई क्या है। पहला इंटरफेस है कि उसको बस कहीं से ये मैसेज आ रहा है कि आज आपको क्या करना है, क्योंकि उसको उतना ही मालूम है, उसको उतना ही चाहिए। उसको ये नहीं चाहिए कि आपने कैसे बताया। उसको इतना चाहिए कि भाई आज मुझे इतना फर्टिलाइजर डालना, ठीक है, और या इस मंडी में बेचना है। तो वी स्टार्ट विद डिसीजन बैकवर्ड एंड वी से पहले मैं एक ऐसा सिस्टम बनाऊं जिसमें सिर्फ आपको डिसीजन के बारे में आपको हेल्प करो, डिसीजन सपोर्ट सिस्टम जैसे सर बोले। तो पहला इंट्रोडक्शन ये है कि डिसीजन दे दो। फिर क्या होगा, धीरे धीरे उससे फिर डेटा कलेक्ट करना शुरू करो कि भाई आप रोज अपना लॉग करो इन्फॉर्मेशन, आज आपने क्या किया, राइट, क्योंकि वो हेल्प करेगा हमें आपको बताने में आगे। फिर आप अपना लॉग करो कि रोज एक फोटो ले लो क्रॉप्स की, उससे पता चलेगा कि आपके क्रॉप हेल्दी है कि नहीं। उस डेटा को सैटेलाइट डेटा से जोड़ के हम अपने मॉडल अच्छे बना सकते हैं। लेकिन इतना कॉम्प्लेक्सिटी उन्हें बताने की जरूरत नहीं है। इफ यू जस्ट टेल देम व्हाट दे नीड टू डू to be part of the symbiotic AI ecosystem. See, it's a symbiotic thing. If they don't give us data, we cannot do anything about that, right? So anyway, satellite data is giving some data, but they also will be part of the AI journey of India's AI transformation for agriculture. उसके लिए उनको उस लेवल पे एजुकेट करना है कि अगर आप अच्छे से डेटा कलेक्ट करोगे, रोज अच्छे से लॉग करोगे, राइट, तो और अच्छा हम एआई से आपको बता सकते हैं। आप अगर रोज एक फोटो अपलोड करोगे तो आपको हम और अच्छा प्रिसीजन दे सकते हैं। तो एक तरह से उनको ये नहीं बताना कि गाड़ी चल कैसे रही, उनको ये बताना है गाड़ी चलने के फायदे क्या क्या हैं आपके लिए। वहां से स्टार्ट करेंगे और आपको क्या करना है कि ये आपको करना है 5 चीजें, अगर आप ये करोगे तो एआई आपको ये वापस देगी, बस उतना ही है ना। तो उससे वो
absolutely,
जल्दी से समझ जाएंगे, इजीली दे विल अंडरस्टैंड।
absolutely true, sir. So the thing is
I
that
just,
we should not go in
I
technology.
just,
Yeah, sir.
I
Yeah,
just
sir.
asked
Sir.
something.
Yeah.
Tell sir में जो example है, even I give the same example to my people also कि होता क्या है कि see we are from agriculture background, और अगर मैं अभी भी अगर कहीं पर मैं अगर सर्च करूंगा कि I need to learn AI और machine learning, मेरे को ऐसे ट्रेनिंग इंस्टीट्यूट मिलेंगे कि जो मुझे कोडिंग सिखाएंगे, और कोडिंग में 1 दिन 2 दिन सीखूंगा फिर भाग जाऊंगा। तो यही होता है कि हमें गाड़ी का इंजन नहीं सीखना, हमें ये सीखना मेरे को कहाँ क्लच ब्रेक और ये करना है, स्पीड लिमिट क्या रखना
True, sir.
है।
True, sir.
नंबर 2 पॉइंट क्या है कि मैं आजकल का स्टार्टअप इकोसिस्टम के बारे में बताता हूँ। मेन थिंग इसी डर की वजह से मोस्ट ऑफ अवर एग्रीकल्चर स्टूडेंट्स आर नॉट कमिंग इनटू दिस बिजनेस सेगमेंट। आप देखोगे तो सारे के सारे इंजीनियर्स भरे हुए हैं, आईआईटीज वाले भरे हुए हैं। So they are running all this show. They know how to build the car, but we know how to drive the car. हमें गाड़ी चलानी है, तो कॉन्सेप्ट हमारे पास है। सो इसके लिए हमें क्या करना है कि जो ये जो स्टूडेंट्स हैं, अभी जो करंट स्टूडेंट्स हैं ना, दे हैव टू शिफ्ट देयर थिंकिंग फ्रॉम ट्रेडिशनल वे ऑफ एग्रीकल्चर टू द डिजिटल वे ऑफ एग्रीकल्चर। अगर आप चीज समझ जाओगे तो आप जाके वही समझा पाओगे। सो वही सर जो बता रहे हैं ना कि हमें सिर्फ उन्हें बताना है कि इसके बेनिफिट्स क्या हैं, यूज क्या है, यूज कैसे करना है, उसके पीछे क्या टेक्नोलॉजी है हमें नहीं समझ, इस मोबाइल के अंदर क्या है मेरे को नहीं मालूम। बट कैसे इसको यूज करना हम लोगों ने सीख लिया कि नहीं? आज हमारे बच्चे 1 दिन में 2 दिन में सीख जाते हैं. If they are 1 year old also, he knows how to swipe, but he doesn't know what is inbuilt there. So
Agreed, sir.
हमें वो दिमाग से निकाल देना, mindset change कर देना.
Yeah, I hope Archana ji, you got the answer. And there was also one more question was asked by the Rupesh that in agriculture education that how we can implement this. I think this answer is already also got in the same question. So let's
No,
quickly
I
go
think
to
that is
one more.
sir, I think, Dinesh sir, I will seek your guidance on this. I think our traditional education in agriculture today in the universities must have an AI program. Must. It's a must now. And at this level of abstraction, not at the coding level, so that our next generation AI experts should be AI aware and they should know what all can be done by AI, what they are learning how to do. If they were physically present, they can do certain things, but they cannot be physically present with all farmers at all times. So AI can be present with all farmers at all times. Once they understand this mindset, and then how do they help in creating such AI systems? So today, domain experts, like you said, are separate, and data scientists and engineers are separate. We need to lock them in a room for 1 year and say you build a agriculture AI platform for the country. Only
Agreed.
then you are allowed to come up. And I think this can only happen when the two types of people come together. So, sir, I really need help with people, leaders like yourself, to make this possible, right? Otherwise, we'll remain in our silos. We will not know what right products to build, and agriculture experts will never know how to use technology.
Absolutely, Shailesh sir. That's what exactly the intention to arrange this webinar. Since last 3-4 webinars, we are running the techno-based webinar series that in AI, ML, data science, so that whatever the agri graduates or the agri starters are there, though they don't have that technical knowledge, they simply like the speakers, the experts like you are explaining well. At least they can know the ABCDs of these technologies. So really appreciate, sir, your valuable inputs also. We'll definitely try to put these suggestions to the manage as a being a Ministry of Agriculture institution. They will definitely put their inputs on behalf of you that it should be inculcated in the agriculture education system as well. Probably we'll take only one last question due to time constraint. The Arikata has raised his hand. Saurabh, could you unmute him so we can take his last question quickly? Can you hear me? Hello? Arikta is there?
Hello.
Yeah, you're
Yes.
audible. You're audible, sir. Please quickly ask the question.
Hello, sir. Good morning, everyone. This is Karthik Ariktota. I'm a diploma in agriculture student.
Yeah, please go ahead.
Here, my question is going with, sir, many of the scientists, like not from the here, they're describing that AI may be harmful for the future. But getting into agriculture, is any damage for the future by using this AI?
Good question. Sir, you want to take? I can take also.
Yes, please, sir.
Okay. So see, technology is never harmful. People using the technology are harmful. Always remember that if you look at the history of human civilization, we have created nuclear energy, nuclear technology.
Yeah.
Unfortunately, the first thing we did with that is to destroy 2 cities. Then we realized, no, it's a very powerful technology. We should create non-proliferation treaty, only use it for, generating electricity. Same thing with internet. First internet came, we filled it with all kinds of junk. Now we are realizing we can actually use it to do digital education, right? So the idea is every technology, the way it is used is what makes it good and bad, right? If you use AI to build drones, which are military and missile powered drones, then we will destroy humanity with AI in 5 days. That is also possible. But if we use the same drones to do agriculture better, precision farming, we will redeem humanity in 5 days. This is up to us how we use it. So there is a course called Ethics in AI. And I think ethical and moral values of humanity have to be pushed at least as fast as the way technology is being pushed, so that all it takes is one bad guy to press the button. right? And that is what is the big danger. So your question is very true. There are many, many leaders in AI world who are worried about that one guy who will misuse it, because we are putting so much AI in open source now. Anybody can build fake images and videos. Now imagine what misuse you can do. People can change elections by saying something on Twitter, right?
Yeah.
The idea is there are misuses of AI that are happening. We need to be aware of that. We need to be conscious, and we need to highly regulate it. So right now in the governments, many countries, we are having regulatory bodies who are saying privacy is important, fairness is important, right use cases are important, data ownership is with the data generator, not the data collector, for example, right? The satellite data of India belongs to the country, not a particular insurance company. So how do we create regulatory frameworks around AI is now happening. And this happens all the time, that technology moves very fast, regulation moves much slowly, because by the time we realize that technology can be misused, already some damage is done, and now we are going to redeem ourselves, right? Same thing happened in genetically modified crops, for example, in the agriculture, right? So every technology will have pros and cons. We have to be very careful. These are very powerful technologies. Genetics is a very powerful technology. It can destroy the whole earth if we do it wrong. COVID virus is one example, right? Same thing, AI is a very powerful technology, and like they say, with great power comes great responsibility. So I think we should use it in a very responsible way.
I think, sir, this last question, actually the verdict of the whole session, I can must say that technology is actually the power. It's up to you, the ethics we should learn, where you are actually and how exactly you are using it for what purpose. And it makes sense to get your solution or make yourself trouble, not you, but to the world. So I think with this, I think we will come to the end of the session as due to the time constraint. But still, there are so many hands are there, questions are coming, and they're requesting the speaker details also. So you can ask this detail these questions, and you can be in touch with the speakers. There's details we are putting in the chat box. Also, the participants who have registered for this webinar, their PPT presentations and the details of the speakers, we are sending them through over email also. And if you want to be in touch with also regularly, you can just follow our social media pages. You can visit our website where the regular updates you will see. Like this is the 143rd webinar. Next week also one more technology based, IoT based technology we are discussing. So you can come up with the suggestion and the feedback for the today's session also in the feedback form too. You can be in touch with regular us. But for time being, we have to say thank you to the today's speaker, because I know they are very experienced people and they're coming from very good, very professional background, but still they make it out some time for us and for our startups. So I would say thank you from my bottom of heart, from entire Manage CIA team and the participants for sparing time with us and guiding us, sir. Thank you so much. And last but not in the participants on my team. Thanks.
Thank you.
Thank you. Thank you so much.
Thank you.